Hello, and welcome to this week's edition of Labrats. So last week you conducted an experiment where we talked about matter. So matter makes up absolutely everything in our universe. This table, the walls, the roads, the vehicles, trees, animals, us. Everything is made up of matter. And matter can essentially have three forms, we learned, and those three forms are solids, liquids, and gases. So last week what we did is we took cornstarch, which is a solid, and we mixed it with water, which is a liquid, and it basically created this in-between substance called a suspension. And what a suspension is actually it is an in-between state. It's kind of like halfway between being a solid and a liquid. And I kind of chose that for a number of reasons. One, it's like a really neat experiment, and the other is because like it's a really good lesson on kind of how everything in life is. So what you would have noticed is that when you move your cup around or would put your spoon into it, it would behave like a liquid. But if you kind of hit the liquid even with, or the material with your fist, or if you'd hit it with a spoon, it would behave like a solid. And that's basically because the particles that make up that cornstarch, they behave like a liquid when they're suspended in water, but when you hit them really hard, they actually lock up with each other, kind of like a puzzle, like two puzzle pieces, and they become like a solid. So this week, kind of riding on that matter train, I figured we would take on an experiment where we're going to grow some crystals, which are obviously also made up of matter. So I'm sure you've seen crystals in your life before, and maybe what you didn't know about them is that they're actually scientifically called minerals. So anytime you see a crystal, the actual scientific word for that is called a mineral. And minerals are really important because they make up all of the rocks in our natural world. So anytime you pick up a rock, it's going to be made up of a whole bunch of different types of minerals. There are something like 9,000 different types of minerals. Only about 36 of them occur in any any large amount in any rocks that you'd ever find. So in your kit this week, I actually gave you some quartz, and quartz is basically what sand is made out of. It's also what glass is made out of. We melt it down to make glass. It's the most common mineral on the face of the planet. I also gave you some fool's gold and some other minerals in your bag, some potash, which is basically made up of table salt, which is called halite, which is also a mineral actually, and a mineral called sylvite. So I just wanted to give you some examples of what minerals look like, and maybe what you noticed in that is that minerals all kind of have a different color, they all grow in a different way, their crystals are different, and that's basically what the point of this lab is today. It's going to be to teach you that minerals do have different properties and that they grow in different ways and can look different ways. So in your kit this week, you would have received a glass jar and a green string with a crystal tied to the end of it, and a purple string without anything tied to it but a paper clip. And you'll also receive two bags, one with a substance called alum, which is actually used in pickling, so in making pickles and stuff, and the other is Epsom salts, which you use in baths, in taking baths. So we're gonna do the Epsom salt experiment just to show you what we're doing here. But what you do is you start out by tying your paper clip like this. You can even bend it in half just to create more of a surface area for the crystals to adhere to. And you tie the end of it to this, and we're going to set that aside. And we're going to take hot water, so you need this to be really hot. It is actually better to have boiling water, but I'll leave that to your parents' discretion whether you want to use boiling water or not. So you use half a cup of boiling water, or just hot water, and you pour it into this glass jar. Then you're going to take your Epsom salt or your alum, you have both, whichever one you want to do first, and you're going to pour in these crystals and stir it until all of the crystals dissolve. So you're going to keep doing this until all the crystals dissolve, and you can no longer, it's no longer dissolving any of the crystals. So you'll notice that there will be a certain point that is reached where all of these crystals will dissolve, and then you'll start pouring them in and they don't want to dissolve anymore. At that point you want to stop. So then you need to actually stir this for like 20 minutes. You actually need to sit here and stir it for 20 minutes. And I know that that sounds like a really, really, really long time, and it is a long time. It's a long time for everybody. But if you don't stir it for that long, you simply will not get the crystal growth that is good. So you're gonna want to stir this for as long as you can. 20 minutes at minimum. If you want to stir it for even longer, you'll get better crystals. So I would recommend that you do that. So you just keep pouring in more of this until your crystals no longer want to dissolve in the water. So you want to, basically what this is called is super saturating your liquid. So that's a chemistry term. It's where you basically dissolve something in water to the point where it can no longer dissolve anymore. So once you've done that and you've stirred it for 20 minutes, which I'm not going to sit here and make a 20-minute video while you watch me stir this, what you're going to do, we'll pretend that this has been 20 minutes. It's like, I don't know, a time lapse or something. And you're going to tie your popsicle stick to your paper clip. So you're going to do that, and then you're going to drop it in. So you want, you're going to want your paper clip or your seed crystal if you're doing the alum experiment. You're going to want it to just be perfectly suspended in the water so that it's suspended but not touching the bottom. So you can kind of have a look at that where it's suspended but not touching the bottom. And then you're going to tie it. Okay, so you're going to tie it up and then you're going to leave it for a little while. So you'll leave it for a day or so, and what you'll see is that the crystals start growing onto the paper clip. And what you'll notice when you do this experiment, you'll do an alum and you'll do this, which is Epsom salt, is that they grow different crystals. And that's because every type of mineral, all 9,000 types of minerals, all grow in different ways. They have different properties about them, which makes us able to identify them. And you'll be able to see that in these two experiments that you do. For instance, I did the alum crystal, and this is what you can end up with if you stir it for long enough. So you can see that it forms little crystals. The Epsom salt ones look different than this. If you want, you can also do the same experiment where you use table salt, because table salt is actually a mineral. And you can also use baking soda, which is the scientific term for that is called sodium bicarbonate. And you can actually do the exact same thing with this, and you'll notice that all four of those will grow different types of minerals, different types of crystals. So those are actually basically the building blocks of what makes all the rocks in our environment. And when you go out and you start picking up rocks and actually looking at them, you'll notice that there's all these different crystals in them, and those are different types of minerals, and that they're different colors, and that they have different properties. And if you really got into it, you could take out a book from the library and actually learn about all that kind of stuff. So yeah, I'm really excited to see if like what kind of crystals you guys end up with. If you want to post pictures of your crystals in the comment section of this video, you can please do that. I thought I'd give you an update on the pea plant before I go. So this is like false advertising. I told you that I would pot this, like put it in soil, which I've clearly neglected to do. But you'll see that it's starting to grow little tendrils here, and peas do that because they like to grab onto things to keep themselves stable. So if you start seeing these little kind of viney looking things growing off your pea, it's because they're starting to get big enough that they want to grasp onto things and like hold themselves steady. So hopefully you guys have planted your pea. This guy's starting to look sad, so I promise you that next time we do a video that I'll actually have planted it and it won't be hopefully so sad. But yeah, if you have any questions, feel free to comment in the video, and I'll see you next week.